Imagine teaching a robot to play a video game. At first, it's clueless, stumbling over every move. But over time, it learns, not because you told it what to do, but because it figured things out by trial and error. It found what works and what doesn't. That's the magic of reinforcement learning. Machines learning through rewards, penalties, and experience, just like humans. Welcome to SmartSlides, the place where we simplify the world of artificial intelligence and machine learning for you. In today's video, we're diving into the fascinating topic of reinforcement learning. Stick around to find out how machines learn to make smarter decisions. Let's start with a relatable example. Imagine you're training a dog. You can't simply explain commands in your language because, well, dogs don't understand human speech. Instead, you use a clever approach: imitation, actions, and rewards. The dog might try different responses when you give it a cue, like saying sit. If the dog does what you expect, you give it a treat. That treat is a reward. Next time, the dog eagerly repeats the same behavior because it hopes to get another treat. That's learning through positive experiences. It's like discovering what to do when things go well. On the flip side, if the dog does something wrong, you might say no as a penalty. This discourages bad behavior. In this scenario, the dog is the agent and your home is the environment. The dog listens to your command and observes its state, such as standing in the living room. When the dog responds to the command by transitioning from standing to sitting, it performs an action. Based on this action, the dog receives feedback, a reward, like a treat, for doing the right thing, or a penalty, like a stern no, for not following the command. Through this process, the dog gradually learns a policy or a strategy to decide the best action to take in any given situation to maximize its rewards. This is the essence of reinforcement learning. Now that we know what reinforcement learning is, let's look at how the process works. Here's a visual representation to guide us. This shows how the agent interacts with its environment. The agent observes the current state of the environment and takes an action. In response, the environment changes to a new state and gives the agent a reward based on how good or bad the action was. This process keeps repeating, and the agent learns from the rewards to make better decisions over time, aiming to get the most rewards possible. Now we'll dive deeper into each part of this process to understand it better. First, let's talk about the agent, the decision maker in reinforcement learning. Think of a cricket batsman. When he tries to hit the ball, he has to decide how to act. If he misses, he loses a point. That's a penalty. If he hits the ball, he scores. That's a reward. Over time, through repeated practice, the batsman learns how to handle specific types of balls. In this case, the agent is the batsman, learning from both success and failure. Next is the environment. This is where the agent interacts and learns. For the batsman, the environment is the cricket field. While the agent, the batsman, can take actions like swinging the bat, he can't change the rules of cricket. The agent takes actions in this environment, but it can't change the fundamental rules or dynamics of the world. For example, in real life, humans can build or destroy things in their surroundings, but we're still bound by the laws of physics, like gravity or the speed of light. In the same way, the agent can influence the environment by its actions, but it must learn to work within its rules. In short, the environment sets the rules, and the agent learns how to adapt and succeed within those limits. Now let's move to state. A state is like a snapshot of the environment at a particular moment. For example, when the batsman sees a fastball coming toward him, that's a specific state. The agent observes the state to decide what action to take next, like hitting, defending, or ducking. And just like in real life, the state is constantly changing as the environment evolves. Let's spend a bit more time on rewards, because they are at the heart of reinforcement learning. Think of a reward as instant feedback. Every time the agent takes an action, the environment gives it a signal, a reward if the action was good, or a penalty if it wasn't. Think of the process as happening step by step in time. At each step, the agent takes an action, which changes the environment in some way. Based on this action and the current state of the environment, the agent receives a numerical reward. This reward tells the agent whether its action was good or bad. For example, if the agent is playing a game, scoring a point is a positive reward, while losing a life is a negative reward. The agent can influence its rewards in two ways. Directly, by choosing better actions that immediately earn higher rewards. Indirectly, by changing the environment in a way that leads to better future rewards. The ultimate goal of the agent is to learn how to maximize its rewards over time, which means identifying and repeating the actions that lead to success. In short, rewards are like a scoring system, helping the agent figure out what works best and encouraging it to improve. Now, let's talk about the policy. A policy is like a game plan for the agent. It tells the agent what action to take in a given state. For instance, if the batsman knows the ball is coming at a certain speed, the policy might tell him to play a defensive shot. The policy links the state to the action, helping the agent make better decisions. Now, let's talk more about the value function, which goes beyond immediate rewards. While rewards are about short-term wins, the value function looks ahead. It calculates the total reward the agent could earn in the future if it starts in a certain state. It predicts the total reward the agent can expect if it starts in a certain state and follows its current policy. For example, let's go back to the self-driving car. At an intersection, the car might face two options. Take a shortcut through a bumpy road, quick reward but risky. Take the main road, which is longer but safer. Less immediate reward but better overall outcome. The value function helps the car evaluate these options, balancing short-term and long-term rewards. It ensures that the agent doesn't just chase quick wins, but considers the bigger picture, maximizing rewards over time. And that's an introduction to reinforcement learning. To sum it up, reinforcement learning is all about learning through experience, balancing short-term rewards with long-term goals, and making smarter decisions over time. If you found this video helpful, don't forget to give it a thumbs up and subscribe to SmartSlides for more AI and ML content. Got questions or suggestions? Drop them in the comments below. Thanks for watching, and I'll see you in the next video.